So let's talk about elementary programming. Elementary programming basically is essentially you are going to learn about what primitive data is there in Java, what type of operators, what type of constants, what are variables, what are operators, make expressions, and see how you can input and output data into a program in Java. Few things. So things to note is essentially what are variables, what are constants, what are data types, operator, expressions, and input and output. So how you take input into Java and output out of Java to see results. Okay. So objectives. So you're talking about there are a few things we'll talk about is the scanner class. We'll talk about byte, short, int, float, double. We'll talk about how to read these values. We'll talk about some of the operators that do things, and we'll talk about power function, and we'll talk about little bit about time, how to measure time. Okay. So first example is computing an area of a circle, where a program calculates the area of a circle. The area of a circle essentially is pi into r square, which is equal to pi, which is value is 3.142 into radius into radius essentially. So let's look at what it does. So that's the program where first thing we need to do, which is called a double. Now double is essentially a type of variable which is for decimals. So if you have 7.934, that could be taken as a double because it has a decimal value and there are numbers after the decimal. Okay, radius could be 5, radius could be 7.3, radius could be 8.4. So there is a possibility of having decimals in there. That's why radius needs to be a double. Similarly, area, now you are multiplying any number into 3.142. That means it has decimal points. So when you multiply, your area will always be a double. That's why it's good to have both of them as double. So you are defining radius as a double and you're defining area as a double to start off with. Then what you do is you assign radius to be equal to 20. That means you put a value of 20. Now you are putting something which has no decimal, but in the memory of for radius it will be 20.000. Okay, in memory. Even though you are just writing 20, it will be 20.0. So the area becomes radius into pi, and this line is actually used to display the area. Like if you want to output to screen, out signifies you are outputting to screen. And println basically says I want to print a line and then I want to move to the next line. So it will print, it will say, so in println this basically is text, you add radius to it. So whatever is calculated from here comes in here, and then is and then area, whatever is calculated here comes in here. Okay, so initially when you define, it allocates memory. So it's allocating this in memory and saying okay, there is no value in there. Similarly, it is allocating for area in memory and no value associated with it. Okay, the next step is essentially once you say radius is equal to this thing, then it assigns 20 to radius. So you see, you're saying radius equal to 20, that is actually assigning value of 20 here because there is no value initially. Then you say area equal to this number, then when you assign this assign, it actually goes into here. Similarly, when you assign, you see, then it actually goes into here and puts that value in there, because unless you don't assign it, there is nothing in there. Similarly, once you are done with both of them, then it actually takes the string. So if I'm taking this bracket and putting it out here, it says the area of the circle, which is essentially a string, plus it takes the value from here, which is radius is 20, plus is, which is again a string, plus area, which is a value from here, which is essentially 1256.636 and you get this answer. So when you look at this, this is this string plus this guy plus this guy plus this guy giving you this value here. Then, so now if we were to read a value from the console is basically, if you go into Eclipse, there is a window which is called console. So if you want to read a value by the user, then you read it from console. Then you read it from console. Okay. Now in that case, what you're doing is you're saying, okay, I want to read, I create an object called scanner, and I want to read input. So in stands for input from console. Okay. And you use the method next double to take a value as double because you are defining it as a double here, you see, and you're taking this input from the screen. So what it does is you say, okay, this tells the user I want to need a double value. Scanner says, okay, I want an input to be read as an input, that is anything which is inputting on the console, I want to capture it. And this is the double value that you put on the console, it will read that double value into the variable called D. D now is input from console as double. Okay. Next thing, so there is something called identifiers. Identifiers are sequence of characters that consist of letter, digits, and dollar symbol. You can actually, an identifier must start with a letter or an underscore, essentially, or a dollar sign. Okay. So there are also something as Java key. Identifier cannot be a reserved word, which essentially is like if, while, public. So these are all reserved words. Identifier can also be a Boolean, which is basically cannot be true or false. Cannot be true or false, and can be of any length. Okay. So now, so the next thing that comes is variables. So variables are basically values that you can actually use in your program. So see, we create a variable called radius, which is of a value, and now the other alternative is just putting 1.0, 1.0 into 3. But assuming you want to reuse it again and again, then you have to call it a variable essentially and define it. So the radius, which is value 1, so here 1.0 comes in, 1.0 comes in from here. If you change this to 2.0, then 2.0 will come in here, 2.0 will come in here, and when area is calculated, then it will calculate 2.0. Like an example, this, you see, then 2 is here, essentially calculating the area to 2. So variable you have to declare. Now this is declaring small types of variable. Integer is a variable, double is a variable, car is a variable. Integer basically is a whole number like 1, 2, 3, 4, 5, 6, 7, 8, 3746, Double is basically a decimal, which is like 0.76, 3.765. This is int. This is double. 7.392. Character is basically a character is like, so A is a character, B is a character, C is a character. So these are single text values, or you can have 7 as a character. So some characters like that. So that's a character variable. Then you can say you are assigning a value of x. You are assigning a value x equal to 1 to the variable x. Then you are taking radius, which is a double. You are assigning it 1.0, and you are assigning character A as a value A. So assignment is putting a value into a variable. Okay. Declaring, you can declare and assign at the same time, like that is basically initialization. So when you assign, it also is called initialization. Assignment or initialization. Okay. Declaring and initialization in one step. You can also declare this is declaration, and this is initialization. You can do it in one step, that you're declaring D as a double and you're saying D value is 1.4. Similarly, you can have constants which don't change. So there are some values that will not change, like pi will not change, correct? So you won't have different values of pi. So final value, you can say final double, where you're defining pi and then you're putting a value in there. A lot of constants, like e is a constant, pi is a constant. You can have, there is Archimedes number. There are quite a few constant values that don't change. There are constants that you use in physics that don't change. Gravity does not change. G is always equal to 9.8 meter per second square. So these values don't change. So these can be constant. Also keep in mind, it's final data type. That means double, int, float, constant name, and the value. Okay, semicolon basically tells you it's the end of the statement. Naming conventions. So you have to name, lowercase consists of several, there are several naming conventions. One of them is basically your variables are lowercase, everything is lowercase, and methods are mixed case. Essentially, that's one way of defining variables. Naming conventions. So class name, capitalize the first, and it can have mixed case actually. Constants are always, you can capitalize constants, like pi could be capital Pi. Say if you wanted to define a max value for any calculation, then you can say max value as capital or min value as capital. Okay. Different numeric data types. Numeric is numbers, correct? Numbers could be decimals, could be integers. So there you go. There's a byte numeric character, short, essentially tells you the range of the number, essentially, and also the size of the number. Okay, like 16-bit, 8-bit, then you have 32-bit essentially for a float, which essentially is a decimal, you see, and then this is also a decimal. So it has a negative range and positive range. So if you have a number line, 0, this is negative, this is positive, so it goes to, so this goes to negative range, positive range goes up to the power of 308, negative range goes up to the power of 324. So it's a 64-bit integer. So like so you say 1.09 into 10 to the power of 9 essentially is a, it's called the scientific notation, which is this notation. Okay, so this tells you these are all number data types. Like you can store numbers. Numbers are decimals or integers essentially. Okay. Now you see you have an int, you have a long, two types, 64-bit sign, and similarly you have a double which is 64-bit. So so if you wanted an integer, you can use this, or if you wanted a double or decimal number, you could use this. Then you can read with scanner, you can read different types of variables from the keyboard. You can read a byte if you wanted to, short, integer. You wanted to use double, you can use this. This we used in one of the assignments, so you should be familiar. You could also use float, but float is of lesser size if you look at this. Okay. So these, you see, look, it says reads as integers. This it says reads as numbers. So it could be integer or double. So if you put in 1, it will read it as 1.0 essentially in this case. Okay, few numeric operations. So there is add, subtract, multiply, modulus basically tells you remainder, as this says, remainder. So remainder of say 7, 3 will equal to 1, 9, 3 will equal to 0. That because 3 goes into 9 3 times, so no remainder. Goes into 2 times, so 1 remainder. So if I do division, so this is giving me the right value if this is double. Now if I say 1.0 by 2, then it will give you 0, because this is an integer. When it divides, it creates an integer. Keep that in mind. So if you miss the 0.0, this will give you a 0. But if you have 3.0 divided by 2, it will give you 1, not 1.5. Not 1.5 because of this value. Keep that in mind. Because this is an integer, the answer will be an integer which has no decimal points, and it approximates down. So see, in 5 by 2 yields 2 because this is an integer. 5 by 0 yields a double value of 2.5, so you got to be careful. So if one of them is double, it will, but if not, then you have to be careful on how you use these things. 5% 2 will equal to 1 as discussed earlier. Similarly, you can calculate the number 6th day of the week, days of the week by this way. After 10 days, remainder, so it will calculate the bracket first, then it will calculate the remainder of it, and then it will give you the answer. So 6 plus 10 is 16% 7. So 16% 7 is equal to 2. So you can write a program to obtain minutes and seconds, which is done, you can do this, and that outputs the math here. Calculation of floating point numbers are approximate because these numbers are not stored with complete accuracy. So given an example, so that's a number, and that's not this, it's basically something like this. This is approximately that much number. Integers are stored precisely because they don't have any decimal. So calculations with integers that read precise integer results. Keep that in mind. So power is basically 2 to the power of 3. That means 2 into 2 into 2, which is equal to 8. Similarly, power 0.5 is basically root of 4, which is basically 2. Or 4 to the power of 0.5, which is again 2. 2.5 to the power of 2 is 2.5 into 2.5, which is 6.5. 2 to the power 2.5 to the power of minus 2 means 1 by 2.5 square. Essentially, minus means, it's the denominator. Numeric. So literal is a constant value that appears directly in a program. For example, 34, these values are literals. Int I equal to 34, long equal to this, these are values as literals. So that's the statement that actually defines that. So you have integer literals, which is between this range to this range. That's a pretty big number. But keep in mind, it's minus 32 because to this minus 1 because 0 needs to be in here. That's why. So few more things. 1000 cannot be stored as a variable or a byte type because it goes out of range. So you have to store it as an integer. So there is a range. It's byte. If you look, it's a certain size. So if you store something which is larger than certain size, it will give you, it's an error. Floating points are written as decimal points with decimal points, but floating point is treated as a double of type value. So 5.0 is considered to be a double value, not a float. So you can make numbers of float by appending the letter F. So if you write this guy, then it makes it forcefully a float, and this guy or this guy makes it a double. Like assuming you wanted to store something as a double, then you can actually say 100.2 D, or so there you go. The double type of values are more accurate than float values. So keep that in mind because float is an approximation, because this is an approximation. Keep that in mind. So 1.0 by 3.0, 1.0 by 3.0 essentially will be 16 digits of 33333, and this is approximate. So it makes it approximation into 7 digits, basically make it a 3334. So it rounds off the last number. Scientific notation is basically this thing into to the power of e. So e is e. So that is basically, so e to the, so this is the same as this. So 10 to the power of minus 2 basically means you have 1, 2, 3, 4, 5, 6. And if I say into 10 to the power of minus 2, that means it shifts, minus shifts this way. So it becomes 0.0, 1, 2, 3, 4, 5, 6. Now if I do into 10 to the power of 2, that means if I do 1.23 into 10 to the power of 2, then it shifts this way, so it becomes 123. Shift the decimal from year to year, so the decimal becomes year, so this number becomes 123. Arithmetic expressions. So these are expressions basically talking about how maths. 4x becomes this guy, 10y becomes, you multiply essentially, and then a plus b by x, and that's how multiplication and division is this way, and 9 plus x has to be bracketized so that it's added first before dividing by y. So you need to add this first before you divide by y, so that's why it's adding bracket and then divide by y. So how to evaluate an expression? Java its own way to evaluate behind the scenes. So it uses the same rules. It uses parentheses, multiplication, multiplication, then addition, addition, and subtraction. That's why parentheses, so it will do this guy, then do the division, and that's what you want. So problem, Celsius to Fahrenheit. So F by 9, Fahrenheit minus 32. So you do 5.0 by 9, so you get a double here. And then Fahrenheit minus 32 basically will evaluate first, and then it will multiply by this number. This is evaluating, and then both will multiply. So this does first, same time, and then the multiplication happens. So current time, you can display current time. Current time is a method in systems class that returns the current time in milliseconds. And you can compute current time by showing current time. So system.current time millisecond actually shows you current time. This is the only thing you need to know. Assignment, addition. So you can add and do the same thing. So I plus 8 is the same as I is equal to I plus 8. I minus equal to 8 is I is equal to I minus 8. Into, divide equal to is the same thing, and percentage equal to is the same thing. So you are taking the older value of I, taking %8 and then storing into I again. So you can do pre-increment, that means the increment happens before using it. This increment happens after. First it becomes 2, and then later on it is still 2. In this case, first it's 1, and then it increments after. Similarly, first it's 0, and then it's 0 the same way. First it's 1, and then the increment happens after that. So post and pre, it's important. Pre means it happens before. So increment happens, so your decrement will happen before, and then, so the values don't change. In this case, the values change, you see. So initially it's 1, and then it becomes 2. Similarly, plus I plus plus gives you this plus plus I, you see, slightly different. So I is equal to I plus 1, that means this is happening before and then the value, and this is happening after. So if you know your for loops for counters, this is important. So I can give in your for loop I equal to I plus 1 before print, and I can give you I equal to I plus 1 after print. So both will have different results. Keep that in mind. Increment and decrement operator. Increment plus is an increment operator. So plus plus variable, variable plus plus, minus minus variable from the previous 2 pages. So number type conversion. It is possible that you convert integer to a long or a double. You take an integer here, multiplied by this, take another long here, take a byte here, and then it will create it into double. This is a number conversion. This happens automatically. It is possible that you may use I as an int I equal to 5. Now I say double d equal to 3.07. Then if I do d into I, then it will do 3.07 into 3, that makes it into a double. So this is automatically converts. Keep that in mind. Conversion rules: if one of the operator is double, the other is converted to double. If one of the operator is float, the other is converted to float. One of the operators is long, the other is converted to long. And both operators are converted into int. Otherwise, both operators are converted to int. So casting actually is a way of actually forcefully converting. So this is a double. So you are forcefully converting into an integer. What does that mean? That means I becomes 3 and the function part is truncated in this case. So I becomes 3 again here. So 3.93 becomes the same. So range increases. So this is 8, 16, then these are, number, and this is 64. So the value size increases as you go on. So type widening is basically making a larger value that you can actually fit in. Type narrowing is basically, see, double is 32, double is 64, integer is less. So what happens is, if it's a longer number, it gets truncated into a smaller number. So if you convert a byte to short, range increases. If you convert double to short, range decreases. Keep that in mind. If you convert double to int, range decreases. If you int to double, range increases. It just becomes a wider number, more digits you can store. Keeping 2 decimals after decimal points, right? So 2 decimals. So in that case, if I want to keep 2 decimals, then what I can do is I can cast. So in this case, let's see. Let's go to the code. Oh. So argument, you can do op equal to x to implement it. So let's skip this. Okay. So software development process. So when you create a software, first you give a requirement. That's your question. Then you see essentially how to program. Then you check if your logic is okay. Then you program it. Then you test it to make sure the results are okay. And then you use it. And if there are changes, then you make changes if you need them on usage. Okay? Question basically, requirement, gather what you need to do. Okay? There you go. So requirement seeks to understand the problem and the document detailing what the software needs to do. Okay? Second thing, analyze the business process, determining data flow, identify. Basically what your program is going to do. Understand that. What your program is going to do. Understanding that. Similarly, system design involves process of designing the component. So if you have a function, then you design a function here. If you have, multiple functions, you design multiple functions here. Or if you are, so you design essentially in this step to see what you need to accomplish. Implementation, so this is process. So this is the input-output process where you are taking inputs for requirements and designing what the software is going to do. Next step is implementation. Implementation is essentially you are taking the code and you are opening the program and writing the code. So you are writing code here. You are writing code using the specification and the design that you have done actually. Similarly, testing, you test how your program actually works, if your code is doing what you need it to do essentially, and do any bug fixing. Similarly, deployment is you ask somebody to use it, so that's your deployment. It could be installing a program, it could be doing several things. And maintenance is if there is a problem, then you go fix it. So loan payment calculation basically. So that's your this thing. And then what you do is the program user, so this is defining what the problem is. So this is your requirement gathering. So what it needs to do is it needs to report listing of values which are dollars, quarters, dimes, nickels and pennies. So some errors, you may have undeclared variables, one thing. Integer may overflow, that means you are putting in a value in a variable that is not suitable for that variable. You round off. So like if you are doing, say, an example of rounding off error is pi is 3.14, you may define it in such a way that pi becomes 3 if you make it an integer. So that's a round off error. Intended integer division, accidentally you actually do 3 by 2, which makes it an integer division, and the answer remains 1 instead of 1.5. So you don't get 1.5, you get 1, and actually you needed 1.5. So see, there you go. So there is your initialized variable. You do interest is equal to 45 days. Now you've not defined this guy. So this is undefined. So if undefined variable you multiply, that's an error. So you have to define this variable before. So you have to say, now in this case your interest rate, R is capital, R is small here. Interest rate, there you go. So these need to match if you want to use them. These need to match. So this needs to be capital R. Similarly, int value. So you put this value and you add 1 to it. It actually goes out of range because this is a certain range value that you can store. Anything over it, it will not store it properly and it will change the value. So that's another issue. So round off errors. So this is basically rounding off errors essentially. Then you can do number 1, you can do number 1 by 2 or 2.0. So it is possible 3. So this is 3 by 2 and this is 3 by 2.0. Now this one becomes 1.5 and this one becomes 1. So there is a division, unintended division error because of this guy. And then pitfall, redundant output. So you can take an integer and then you can define it again. So if you define it twice, then that's an error essentially. You have to define it once and then you can reuse it again and again. Also, the issue is, another issue is you are taking an input as integer and then you are taking a double. Keep in mind, you are changing how you are defining it. So this is an input one variable, so input variable, input one variable. So that's okay essentially. But if you redefined it and called it input, that's a problem. This is not allowed. You cannot redefine the input. Similarly, so another, so you define as double, you define. I think that's it. Thanks.